Okay, now that we're done with Chapter 4, we're going to jump a little bit in our textbook and move on to Chapter 13, Matrices and Determinants. Alright, sounds exciting, doesn't it? Well, the fact that we worked a little bit with matrices in Chapter 4 when solving systems of equations makes this, to me, a natural jump. So we're going to start out in the first two sections. They're fairly straightforward. The first section, 13.1, is determining the dimensions of a matrix. And you know, when we were entering our systems of equations into the matrices, we had to tell it what the dimensions were. It's always going to be rows by columns. And then we're also going to be adding and subtracting matrices. So I think we're ready to go. As a little warm-up, let's go ahead and remember how to put equations into standard form, where standard form is ax plus by equals c, where x and y are the variables and a, b, and c are integers, meaning not fractions. So down here, this negative 1/2 is going to need to be taken care of. But let's go ahead and see if we can at least get it ax plus by equals c without integers, and then see what we can do to turn them into integers. Alright, take a minute here and put these equations into standard form. You're probably wondering how that x just jumped in there. That was my mistake. I put it in, so ready, go. Put this into standard form. Okay, here's what it should look like. So first off, we're going to make sure that the x and y are on the same side. So in order for me to do that for this equation, I need to subtract this 5x from both sides. When I subtract it from this side, it becomes 0. Now when I subtract it from that side, these are not like terms. And so now it looks like that. Ooh, I probably should have switched the order of the x and the y, knowing I need to go x and then y. I can do that in a second. Let me come down here and do the same thing. So I want to bring the x over, so go ahead and add 1/2 x, and I'm going to be smart enough this time to write the x first. So positive 1/2 x plus y equals, and then we're left with only a 2 on that side. Alright, so now let me go ahead and fix this all up, on the top at least. So on the top here, now I get I'm going to do the x first, so I get negative 5x plus 4y equals negative 3. And then down here on the bottom, I almost have it except this 1/2. Because that's not an integer, this isn't technically standard form yet. So what I need to do is I need to get rid of the 1/2, and that's going to be done by multiplying both sides of the equation by 2. So if I multiply everything by 2, this now becomes x plus 2y equals 4. Now we have it in standard form. Ax plus by equals c, and ax plus by equals c. So very nice. Now we're ready to move on. RC, this is going to be an abbreviation that you want to know and be familiar with as we continue moving forward. It stands for rows by columns. Alright, so here we go. An m by n matrix. By the way, a matrix is simply a rectangular array. It's an organizational system that is done in a rectangle, and a rectangle will have rows and it'll have columns. In this case, in this example here, where I'm not using any numbers specifically, I have m rows and n columns. Rows, columns, rows, columns. And so this is an m by n matrix, so we have m rows and n columns. M rows and n columns. So rows travel horizontally, so row 1, row 2, row 3, row 4. Here's column 1, column 2, column 3, and column, well, I guess it's not 4 technically, column n, and this down here was row m, because I don't know how many rows I have. I got these little dots here telling me that it's continuing on, and I don't know how many are in between. And now my little notations here. So this is saying that this is element A in the array, and specifically row 1, column 1. here, this number here is element A that's in row 1, column 2. This element is in row 1, column 3. And that's the notation. These are called subscripts because they are written below the number. It's really just an organizational number. It helps you keep track of where things are. So this element right here, whatever number this is, you know because we're calling it A sub 32 that it's in row 3, column 2. This one right here is in row 2, column 3. So it's a nice way of keeping things organized in a rectangular array, which we call a matrix. Alright, let's see if you can tell me the dimensions of this matrix. What are the dimensions of this matrix? Alright, well I have the dimensions as 4 rows and 2 columns, so we would say that this is a 4 by 2 matrix. Alright, way to go. Nice job. Alright, moving on. Rows by columns. Don't forget rows by columns. Alright, what are the dimensions of these 3 matrices here? Put me on pause, take a couple minutes, and write down what you consider to be the dimensions of matrix A, matrix B, and matrix C. Okay, here you go. Matrix A, 2 by 4, B, 5 by 2, and C, 1 by 4. Number of rows by the number of columns. RC, rows, columns. Also notice that whenever you give a matrix a name, you call it a name with a capital letter, capital B, capital C, capital A. So matrices are named with capital letters. RC. Okay, now on to the next portion, which is adding and subtracting matrices. In order to add and subtract matrices, the only thing you need to really make sure of is that the matrices have the exact same dimensions as each other. So if I wanted to add matrix A to matrix B, the first thing I would need to ask myself is it even possible to add these together? Because it's only possible if they have exactly the same dimensions. So when I look at these matrices, let's see the dimensions of matrix A. Okay, matrix A is a 2 by 3, matrix B is a 2 by 3, and so therefore, yes, I can add and subtract these matrices. Now, in order to do that, it's very, very simple. Simply add these similar elements to each other. So let's see how I can do this. Okay, so if I want to add matrix A plus matrix B, like number 1 down here is asking me to do, I take the element that's in the first row, first column, and I'm going to take this 4, and I'm going to add it to the element that's in the first row, first column over here, which is a negative 9, and I'm going to put my answer into a new matrix into the first row, first column. So my new matrix will go, let me get rid of this one. So this is going to be matrix A plus B. Matrix A plus B is also going to be a 2 by 3 matrix. And the number that I put into the first row, first column is going to be 4 plus negative 9. And in the second in the first row, second column, I'm going to do 2 plus 4. And first row, third column, I'm going to do 5 plus negative 5. Down here in the second row, first column, I'm going to do 1 plus 4. And then I'm going to do negative 7 plus negative 2 in the second row, second column. And down here in the second row, third column, I'm going to do x plus 3x. And now this is matrix A plus B. And of course, we can clean this up. So it's going to become negative 5, 6, 0, 5, negative 9, 4x. Alright, so that's it as far as adding matrices are concerned. Why don't you see if you can add matrix B plus matrix A? And if you're thinking that it's going to be the same as matrix A plus matrix B, then you are correct. It is the same answer because matrix addition is commutative. Means same forward and backwards. Matrix addition is commutative. All right. What about subtraction, though? Well, subtraction is not commutative in regular subtraction or matrix subtraction, but it is done the same way. First, make sure the matrices have the same dimensions as each other. Once they do, then you just subtract the corresponding elements. Alright, see if you can subtract A minus B. Check back in with me in just a few minutes. Okay, let's see how you did. In order to subtract matrix A minus matrix B, simply subtract 4 minus negative 9, and then over here in row 1, column 2, subtract 2 minus 4, and so on and so forth. And when you're all said and done, you should have this matrix here as the difference between matrix A and matrix B. And then down here, switching the order, all it really does is it changes the signs on all the elements. So you should have negative 5, positive 2, negative 10, positive 3, positive 5, positive 2x. And as with anything, if you find a mistake, please let me know in class tomorrow. Alright, continuing on. We're almost done here. Last problem. Let's see if we can solve for x and y. Solve for x and y. So I have a 2 by 2 matrix being added to a 2 by 2 matrix, and the sum is also a 2 by 2 matrix. This makes sense. So now let's see what we have here. In row 1, column 1, I have 14 plus negative 4. 14 plus negative 4 equals 10. That makes sense. 2x plus negative 7 equals 5. That's how I'm going to be able to solve for x. Let's see how that looks. 2x plus negative 7, I'm just going to write minus 7, equals 5. I can solve this, add 7 to both sides, 2x equals 12, divide by 2, x equals 6. Alright, good. Now there's also another variable on here, which is variable y. I need to find y. Let's see, 3 plus 0 equals 3. That's good there. Negative 5 plus 3y equals 4. I think that's what I need. Negative 5 plus 3y equals 4. Add 5 to both sides. So now I get 3y equals 9. Y equals 3. Alright, we solved for x and y. Alright, I hope this is very helpful. Take this and come to class tomorrow being ready to work on assignment number 1 for chapter 13. You guys are awesome.